Hi, my name is Avi Bleiweiss, and I will be presenting a proposal for merging diffusion and language model for the sake of query expansion. Query expansion has been fundamental to information retrieval and question answering domains. In recent years, there has been a growing interest of QE in large language models, primarily using prompt tuning to control the model response. Our work innovates in a diffusion-based generative QE and avoiding the replication of a single query sample. Here we show the outline of our framework. On the left side, we show the Llama 3.1 prompt structure that composes a system role that provides higher level context, the user, which is essentially the initial query, and the assistant that provides the response of Llama 3.1. The query expansion model takes the Llama response, and on the other hand, it either takes a replication of the initial query or a list of subqueries if it goes through the diffusion model. And lastly, we compute a relevant score using the BM25 metrics. To evaluate our system, we use two data sources, a table and a text. FetaQA is a free-form tabular QA that uses high-quality Wikipedia tables. It has a little over 10,000 unique tables and a test fleet of a little over 2,000 instances. On the other hand, Amazon QA is a text-based database. As you would expect, it leverages rich product review. It is much larger than FetaQA. It encompasses a little over 900,000 question context pairs, and the test fleet is of 92,000 instances. It covers 17 categories, and a category has much more samples compared to FetaQA topic coverage. Our method comprises a two-step reasoning. In the first one, we use Llama 3.1 prompting, and we generate an answer based on a concatenation of the query and the local knowledge base. In the second step, we balance the token length of the query with the response. There is a common practice that uses query replication, but in our work we use embedding diffusion, of which we generate a subquery for each epoch of the LSTM training process. Here we illustrate the diffusion forward process. At the top we have the original query at time 0, and then we show the queries at times 1, 5, and 10, by which as time advances we apply a more increased Gaussian noise to the query itself. We also show the losses that shows a decline as time progresses. We highlight some of our results. On the table QA side, we show answer generation by FetaQA and Llama 3.1, and there is a fair agreement between the two raters when we use the kappa measure. On the text QA side, we opted to look at relationships between product groups, and we notice especially a cluster of 4 product groups that appears to be highly correlated, and that seems to be highly explicable. The noise strategy for a diffusion process has several parameters. Commonly used is the uniform Gaussian, but there are also approaches that use perturbed words proportional to their importance. Our experiments show that random scores gain fairly little over uniform noise. Our initial study that integrates in LM the forward phase of a diffusion model for reasoning continuous text generation depicted compelling QE quality. Thank you.